Hi, my name is Jeff Mieleff, and I'm a principal program manager and architect within the Microsoft 365 engineering team. I'm here today to talk about managing connections using the IP and URL web service, part of our network connectivity video series. So the first thing we'll talk about is a brief overview of Microsoft 365 traffic differentiation, how to identify traffic on your network that's associated with Microsoft 365, and then treat it in an appropriate way. We'll spend a little bit of time going through a deep dive of the IP and URL web service and the methods that are available within that web service. And then we'll go through a demo and try and provide some practical examples of how the IP and URL web service can be used within your own infrastructure to keep your devices and configurations up to date. Make sure that you always have good access to the Microsoft 365 services for your end users, and that you are able to optimize performance as effectively as possible. So if you've watched any of the other videos in this video series or seen any of our other presentations in the past on these topics, you've probably seen a slide like this, where we outline our high-level network connectivity principles. The first principle is the one that we're going to be primarily focused on today, and that's around optimizing Microsoft 365 traffic. The other categories that show up here are directly related to that optimization or identification of traffic, in that once you actually do identify that traffic that's associated with Microsoft 365 endpoints, that then enables you to take that traffic and locally egress it, get it out to the internet as quickly as possible, from wherever the end user is who's accessing the service. Enable direct connectivity, so avoid network hairpins and make sure that the path of that traffic is as direct as possible to the Microsoft cloud. And then also modernize security and make sure that you're not performing any unnecessary inspection that has the potential to add significant latency to that traffic path that will impact end user experience. So again, we'll be focusing primarily on that first connectivity principle, but really the applicability of what we're talking about today is across all of these connectivity principles. So how do we identify Microsoft 365 traffic? There's really two primary sort of buckets that the traffic falls into. There's egress traffic outbound from the customer network, targeting our endpoints in the Microsoft cloud. And then there's ingress traffic, and that would be primarily hybrid-related traffic that originates in the Microsoft cloud and is destined for the customer on-premises network in order to enable those hybrid scenarios. In general, all of this traffic can be identified based on being associated with an endpoint. For egress traffic, this would be the destination. For ingress traffic, this would be the source, generally. And these are going to be defined based on some combination of four different attributes: the namespace or the FQDN that the client is attempting to reach, the IP address or addresses, could be a specific address or a range of addresses, the protocol, whether it's TCP or UDP, and the destination port. Not all these attributes are defined for every service endpoint that we document. We provide as much information as we can based on the type of traffic that it is and the category of traffic. And I'll get into that in a little more detail in a moment. Important to understand that as we think about identifying traffic and differentiating traffic in less complex networks, this actually may be a very simple thing to do. In a branch office that has a small number of users and no significant infrastructure complexity, where the traffic is just egressing out to the internet for everything, there's really nothing else to be done. That's going to be very well aligned with Microsoft's best practices for M365 traffic. But when we start to introduce things like corporate wide area networks and backhaul across those networks, proxy infrastructure, these types of things, then we have to add some additional complexity in terms of identifying traffic and treating it differently. With proxy infrastructure, that likely means that we're going to be focused on namespaces and identifying traffic based on the namespace that the client is trying to connect to when it starts up or when it tries to initiate a connection. If we're looking at managing traffic at the IP routing plane, we're going to be looking at IP prefixes. In many cases, we're going to be looking at IP and port combinations as we go to configure firewalls, either for egress or ingress. I wanted to briefly call out Microsoft 365 traffic is not generic internet traffic. And I know some of the other sessions in this series go into quite a bit of detail here, but still there's a lot of relevance to the session that we're going through right now. So just wanted to take a brief moment to reiterate this point that when you think about the traffic that's egressing from your network to the internet, it's perfectly acceptable to not trust generic internet traffic. In fact, I don't trust generic internet traffic either. You have no idea who you're connecting to, who's managing the infrastructure on the other end of that connection, what that content is, who the content publisher is. So totally unpredictable what you're going to get at any given point in time. But Microsoft 365 traffic is not that. In general, the service infrastructure that you're connecting to is controlled and operated by Microsoft within the boundaries of the trust commitments that we make within our service trust portal and audit reports, etc. There's certainly caveats to that I'll mention in a moment with our different IP and URL categorization. But much of that connectivity is actually controlled by Microsoft on the back end. The content that you're actually operating on is your content. It's not our content. It's content that is your intellectual property. User generated documents, emails, the crown jewels of your organization, the super valuable content that your end users create as part of their productivity experience within our applications. So it's not untrusted content. It should be fully trusted because it's your content. And you're very much using specifically designed features and applications around these productivity scenarios. So it's not just a random website. It's actually a fully thought through scenario that's optimized for performance, optimized for end user experience, and optimized to specifically use that content that's stored in our cloud service. So the idea here is, as you think about trust and as you think about treating this traffic differently, you should be differentiating Microsoft 365 traffic from generic internet traffic and trying to do the right thing from an optimization perspective in order to ensure that your users have a great experience and not perform unnecessary inspection of traffic, unnecessary extraneous routing of traffic through particular choke points or security devices when you have that level of trust associated with the traffic. Continue to perform whatever inspection or security you think is necessary for the generic internet traffic, but that Microsoft 365 traffic is a very different thing. So we fully understand that treating all of the Microsoft 365 designated traffic as trusted is not going to happen, and it really shouldn't happen. There is absolutely a taxonomy associated with Microsoft 365 traffic that divides it up into some categories, and we label those categories as default, allow, and optimize. The default category we really think of as effectively being the same as standard untrusted internet traffic. In whatever way you treat that traffic today on your network, you should treat our default category in the same way. If you're performing some sort of inspection on that traffic through some proxy infrastructure, feel free to continue to do that with the default category. And we don't expect that you'll have a negative impact on end user experience as a result. Much of the traffic associated with the default category is actually not terminating in Microsoft data centers. Examples of this would be third-party content distribution networks, non-Microsoft internet services that we integrate with within our products. And so, as an example, we won't, in most cases, provide IP address prefixes for the traffic in the default category because we don't control that infrastructure. We actually can't make an assertion about what IP addresses will be used to deliver those services. We only are really guaranteed to have URLs for the traffic in the default category. The allow category should be a little more trusted than the default category. This is connectivity that's absolutely required to take advantage of Office 365 or Microsoft 365. As opposed to the default category where some of those endpoints are marked as optional. So anything in the allow category you need to provide access to. It is still okay to proxy this traffic without having much of an impact on end user experience. Having said that, we still recommend not to SSL break and inspect this traffic or use authenticated proxy to try and avoid any extreme latency impact from those technologies. And then the optimize category is where you really want to focus your effort when you think about traffic differentiation and trying to treat traffic differently to optimize that end user experience. This is a very small set of endpoints, both in terms of the number of URLs as well as the number of IP prefixes that exist in the category. Everything within this category is 100% hosted by Microsoft within our infrastructure, and so we can make very strong assertions around the trustworthiness of that infrastructure. And again, all of the assertions that we make within our audit reports and things that show up in the Service Trust portal would absolutely apply to traffic that's landing in this optimized category. There's a very slow rate of change with these endpoints. And there's a significant benefit there if you're primarily focused on trying to identify and treat this optimized traffic differently. It means that the churn within your own IT systems will be relatively low. We do have a monthly cadence for releasing updates across the board for all of our published endpoint information, but the actual rate of change on the optimized category is much lower than that. So that's a significant benefit there. Again, we very, very strongly advise you not to SSL break and inspect this traffic or proxy this traffic. We really want to see this traffic locally egressed from the user's location with the absolute minimal amount of delay possible in order to provide a great end user experience. So those are the three categories of traffic that we have. So when is service endpoint management relevant? When does it actually matter that you identify traffic and treat it differently? So there's kind of four major categories that come into play. Performance optimization, I've already mentioned a number of times, and that's probably the most frequent case that comes up, where you want to identify that latency-sensitive traffic and treat it in the best way possible. There's internet egress with restrictions in place. So a number of our customers by default do not allow internet access, and then will only allow access out to the internet for designated websites or internet hosted services. So in that case, you really need to be able to identify where traffic is going to be reaching for Microsoft 365 access in order to allow that access outbound. That could consist of proxy configuration, could consist of firewall configuration, lots of different devices in the path that may need configuration in order to allow that traffic through. There's also cases with multiple egress paths. SD-WAN is a great example of this, where you might have some branch offices that have multiple paths to reach the internet, perhaps a local path, perhaps a path through a corporate MPLS network with some centralized egress locations. And you want to be able to do the right thing for given categories of traffic. Ideally, with the optimized category, you would allow that to egress locally. And you may have reasons to continue to backhaul the other categories of traffic into a central location for further inspection. But again, in that case, being able to configure that SD-WAN solution based on our IP and URL categorization or our taxonomy is certainly critical to success here. And then there's also ingress scenarios with hybrid deployments. So the canonical scenario here would be something like Exchange Online, where you have things like FreeBusy requests coming in from users who have cloud mailboxes and want to interact with users whose mailboxes are on-prem. In those scenarios, there are connections initiated from Microsoft's infrastructure into the on-premises deployment, and you need to know what traffic to allow at the edge of the corporate network, whether it's a firewall or a reverse proxy or a load balancer, whatever the device is that's managing that traffic, you need to be able to configure that appropriately. So we provide detail in a human-readable form on docs.microsoft.com, and there's a short link here on the slide. This is just an easy-to-use web page where you can go get a sense of what the surface area is of our service endpoints. This is not really designed for automation, though. And given that we do have this monthly change cadence, it's really important that you only use this as occasional reference if you need to go double-check something, and not focus on this for automation, and instead focus on the functionality that we provide in the IP and URL web service to build automation and ensure that you have a durable solution to keep your on-premises infrastructure up to date and make sure that you don't run into any outages as we change the endpoint surface area of our services, and as a result, run into the potential for your infrastructure being out of date and not allowing access to infrastructure at a given point in time. So let's do a little deep dive through what we provide with the IP and URL web services. So as I mentioned, the HTML page on docs.microsoft.com is really provided for people, not devices, but we need to provide the same back-end information to devices. That was the reason for developing these web services. Important to understand that we are working directly with a number of hardware providers and solution providers in the network space to actually consume this information directly within their products and allow you to take advantage of the IP and URL web services without actually doing any customization on your own. So examples of this would be things like proxy solutions or firewall solutions that have a very simple configuration option to enable access to Microsoft 365, typically with just a couple of checkboxes, and then automatically keep themselves up to date by calling into the web service methods that we'll talk about in a moment. At the same time, all of these web service methods are also available for you to build automation around if you need to do further customization. So the API documentation is available at the short URL that's listed on the slide. The methods are effectively just RESTful APIs that support output in a couple of different formats, depending on the automation that you're building and what your use cases are. We can provide output in JSON or CSV. We do require that each request that comes in includes a unique ID, effectively a GUID, that we use for telemetry and troubleshooting. And we recommend generating a unique ID per client. So if you have a particular device that's going to be calling in regularly to one of these web services, that would have a consistent client request ID that it uses for each call into the web services. We do recommend following our guidance carefully around how frequently you call these methods to avoid rate limiting or 429 errors. There is a particular method that is called regularly in order to understand if there's new information that's been published. That one's designed for polling, but the others are not. So again, you want to make sure that you follow our guidance around that to avoid any unexpected errors. And last but not least, on general capabilities, we do have multiple instances of the Microsoft 365 services. Most of our customers are in the worldwide instance, but there are a subset of our customers that are deployed within sovereign instances of the service that have different service endpoints. And so there is the ability within the IP and URL web service methods to specify a particular instance and get that information as needed. So as I mentioned, there is a method within the web services that can be used to pull on a regular basis and understand whether or not there is a new version of data that's been published as a trigger to then go and get that full download of information. And that's the version web service. The version web service actually has an additional data format that can be downloaded, and that's the RSS format. If you look on the docs.microsoft.com page where we publish our IP and URLs, there's an RSS feed available there. And that's actually just a link to this web service method with the RSS output format specified, a shortcut there to get some insight into the change history associated with the endpoints data. So the guidance here is to pull no more than hourly if you're building automation that's going to react to version changes. It's the web service is not rate limited, but again, the guidance is to pull hourly and not more frequently. The next method to talk about is the endpoints web service method, and that's really where you get the bulk of the information that's available. As output from this web service, we provide what we call endpoint sets. And so sets are going to include unique sets of services, URLs, IPs, ports, categories, and various other parameters. If you go through the IP and URL webpage, the human readable one, that table is basically built from these endpoint sets. And you'll see the same output provided by the endpoints web service method. As input to the method, you can provide the service areas that you're specifically looking for, or optionally just leave that parameter out and get everything. So this allows you to scope down the results to specific services that you might be interested in. Probably important to call out that the Skype service area is actually Skype and Teams. It's the same service endpoint infrastructure on the back end. So if you're focused on Teams, it's called Skype here from a service areas parameter perspective. We also allow you to pass in your tenant name, and this allows us to substitute tenant-specific URLs for what would otherwise be returned as wildcard URLs. A specific example of this would be the SharePoint URLs that are tenant-specific. If you want to just focus on the URLs that are appropriate for your tenant, then you'd want to pass in the tenant name here, and we'll do that URL manipulation prior to returning the results. And if you're not using IPv6, we provide you the ability to exclude IPv6 prefixes from the results from this method. So here's a quick example of what this might look like in PowerShell. In this particular example, we're calling into the endpoints web service method and then filtering the output from that to just look at the optimized category endpoints for the Exchange service area. In the second example, we're filtering the output in a different way and just looking at the namespaces or URLs that are associated with the optimized category for all of the service areas. And the last method to highlight is the changes web service. And this is used to actually get change history from a particular version up to current. So you essentially pass in a prior version. That's the base version number. And we provide an array of changes that have occurred. And this might be used if you were implementing some automation that was going to keep some sort of a local data store of endpoints and then update them based on the changes that have occurred, as opposed to pulling down a current snapshot of everything from the Endpoints web service and updating via that method. So at this point, let's go ahead and get into a demo that hopefully will help you better understand how the IP and URL web service can be used to help keep your on-premises infrastructure up to date and ensure that you always have the latest configuration information so that your users can access all of our services. So in this demonstration, we're going to have a hypothetical situation with a global electronics manufacturing conglomerate called Contoso Electronics. They have a subsidiary in India who wants to onboard to Microsoft 365. And the subsidiary hasn't used any of our services in the past. The corporate infrastructure for Contoso Electronics has a large corporate wide area network with 2 internet egress locations, one in Europe and one in the United States. The users in India will backhaul their traffic across the corporate WAN to egress in one of those locations. And the overall network is fairly bandwidth constrained and has some issues with capacity for the edge network security stack in both Europe and the US. So there's fairly significant latency for any outbound traffic to the internet from any location on their network, but certainly for users in India, they're going to see some fairly significant issues with latency as they try to use Microsoft 365. So we'll go ahead and walk through how the IP and URL web service can be used to both initially onboard the India subsidiary and ensure that their access is able to use the existing proxy infrastructure. And then we'll talk about how we could potentially optimize things a bit further to provide a better experience for those users. So we'll go ahead and pull up a remote desktop session into a PC in the India subsidiary. The first thing that I want to do is just make sure that we have internet access. So I'm just going to go to the Microsoft website, make sure that works okay. And it looks like we're resolving the name, getting to the Microsoft homepage. And that was a fairly long time to get to the Microsoft homepage. So as I mentioned, we've got some fairly significant latency from the India subsidiary out to the internet. So we know that the internet works. Now the next question is, can we get to a Microsoft 365 resource? And we'll just try getting to Outlook on the web. So outlook.office.com. And unfortunately, we cannot get there. And the reason for this is that Contoso IT has not yet configured the proxies to allow traffic to Microsoft 365 endpoints through the proxy server infrastructure that these users in India are using. So we'll go ahead and connect to one of the management PCs back in the US that our IT staff use. The first thing we want to do is go to the IP and URL web service documentation page. And from there's a couple of sample scripts that demonstrate how to use the IP and URL web service. There's a PowerShell script and a Python script on this page. We'll go ahead and copy the PowerShell script, and we'll save that to a text file here on the desktop. Go ahead and grab the name of it. All right. I'm actually going to go ahead and open that up in Visual Studio Code, which is my preferred PowerShell editor. All right. Perfect. So this script is very straightforward, nicely documented, and goes through all the different methods that we described earlier, where we'll go out and check the current version. determine whether or not the version is incremented since the last time we called the script, and then call the endpoints method to actually pull down some data, which we then manipulate a little bit and dump out into an output file. So what we need to do first and foremost is actually get a list of allowed URLs or namespaces that we want to allow through our proxy infrastructure. And while this script by default will go through and pull out some URLs for the proxy server from the allow and optimize group, what we really want to do is get all of the categories. So allow, optimize, and default. So I'm actually going to add that in here. And I'll just, for consistency's sake, say that we want to use allow, optimize, and default for the IP addresses that we're getting as well. And the other initial change that I want to make, just for testing purposes, I'm going to comment out the code that does the version checking. So keep in mind, this is not something you want to do in production. We only want to do this check against the endpoints method when the version changes, but we will just always assume for the purposes of this test, this demo, that we're calling this for the first time. So we always want to make a call out to the endpoints web service. Okay, so the other thing to point out is that when we're dumping out URLs for the proxy server, all we're really doing here is just dumping out a comma-separated list. And in our IT infrastructure, we're actually running a Squid proxy, and that is expecting a different style of output. It's basically looking for each name on a separate line. And it's also very particular in that it doesn't want any conflicts. So if there are any wildcards which are specified with a leading dot, it doesn't want to see any other entries in the file that would be included under that wildcard. So we need to actually add a little bit of code to go through and remove any conflicts, as well as converting the wildcards to the format that we expect. So I'll paste in a quick little code snippet here. Probably not the most optimal way to do this, but for the purposes of the demo, it'll work. So we're just going to go and create an array list, .NET collection that'll allow us to manipulate the list on the fly. We go through and do some manipulation of the namespace data that was pulled in from the web service. We're going to make sure that the entries are unique. We're going to sort them by length. That'll help us with the algorithm that we've got below. We convert the wildcards by pulling out the asterisks. We just have a leading dot on those. And then we'll just go through the list and look for conflicts effectively and remove them and write out the list to the output file. So at this point, we should be able to just go ahead and run this script. And we'll go ahead and open up the output file. And now we've got this nice list of unique, non-conflicting names, some of them wildcards, some of them fully qualified. So we'll just go ahead and copy that list. And then we'll pop into our proxy configuration. And we'll paste that list in. And our proxy is actually running in a Docker container, so we'll just restart that container, pick up the change. As soon as that is done, go ahead and close that while we're waiting. We should be able to come back here and get into Outlook on the web. So the status down here on the bottom suggests that things are moving along a little bit better than they were previously, which is good to see. And looks like we're getting a login prompt. All right, so our proxy is allowing access now to Outlook on the web. So I'll just go ahead and log into my account here. See that things are definitely not running very quickly, as expected, given what I described about the infrastructure. But it does appear that we now have access to Microsoft 365 services via the proxy. So that's our first example of how to use the IP and URL web service. Again, very slow access to everything here. This is definitely not a very snappy experience with Outlook on the web. So the next thing we can think about is potentially changing the way we route traffic. So as I mentioned previously, we want to look at the optimized traffic and try and egress that locally. And the way we would do that in an environment like this would be to identify that optimized traffic via the proxy pack and configure that traffic to egress locally. So in order to do that, we actually have another sample script that generates proxy packs in a couple of different configurations. So I'm just going to go ahead and run my install script commandlet to get the get pack file script. All right. Now at this point, if I just run the get pack file script, it's going to require that I pass in a client request ID. As I mentioned previously, we always have to pass in that that GUID that's used for telemetry and tracking, troubleshooting on the back end anytime we use our IP and URL web service. So I'm going to go ahead and create a new GUID, use our pack file script, and we'll pass in that request ID. Now, by default, get pack file is going to call into the IP and URL web service. It's going to assume that we want to egress the optimized endpoints locally and pass everything else through the proxy server, which is exactly what we're trying to do here. There is an additional configuration that will allow you to pull the allow and the optimize endpoints and egress those locally, and then pass the default category endpoints through the proxy. But we'll just go ahead and use this configuration for now. So I'm going to go ahead and copy this configuration, and then we'll go ahead and pop over here into our proxy pack. So at the moment, we're just passing everything through our proxy. So we'll go ahead and comment that out. Oops. Try that again. All right, and we'll just adjust the proxy server variable to be the correct value. Save that proxy pack, and then we'll jump back to our PC in India. And I'm going to quickly pop open the settings, force a reload of the pack file, so we can immediately see the change. Close my web browser. And let's try to go to outlook.office.com again. And we seem to have a problem. So let's check, let's check Microsoft.com again. Make sure we can still get to the internet. So it looks like we're still able to get to the internet, but we can't get to outlook.office.com. And that is not surprising at all, because we haven't configured our firewall infrastructure in the India office to actually allow that optimized traffic to egress locally. So how can we do that? Well, we have IP information, IP prefixes that are returned via the IP and URL web service. And so let's adjust our script one more time. So we're already pulling down all of those IPs earlier in the script. They all come down as part of this endpoint sets variable in the script when we call the endpoints web service. So we can add in some additional code that can be used to configure our firewall. In this particular case, the traffic for the India office is actually being managed via Azure, and there's an Azure network security group that is responsible for blocking that traffic currently. So I will add in some code here that simply goes through and goes through our endpoint sets, pulls out the IPs for IPv4 and IPv6 that are within the optimized category, and then writes out to the output file some PowerShell commands that will adjust the Azure Network Security Group configuration that we use with that infrastructure in India to allow the traffic through. So go ahead and save that script file, and we can run that script again. Go ahead and pop open the output file. And now down here at the very bottom, we have these Azure PowerShell commands that are pulling in all of the prefixes associated with the optimized group and allowing access to them. So we'll go ahead and copy this. And within PowerShell, we can just go ahead and start executing those. And we'll just let those run for a little while. Okay, through the miracle of video recording, we allowed time to pass quickly. We've now added, looks like 49 firewall rules to our Azure Network Security Group. Obviously, whatever firewall you have in place in your infrastructure, you can do something similar here and automatically script the process of allowing the necessary address prefixes given whatever format's required by your particular firewall implementation. So I'm just going to make sure all of our rules are added properly. Get Azure. All right. Yep. So we got all of our M365 allow rules configured. And let's go back to our PC in the India office and see if we can get to Outlook now. Recall that we've now adjusted our proxy pack to have the optimized traffic egress locally. We've adjusted the firewall config to allow the IP prefixes associated with the optimized traffic to egress locally. So we'll still probably take a little bit of time here for this one-time sign-in traffic because we're calling out to Azure AD endpoints that are not in that optimized set in order to perform the login. But once we perform the login, we should actually have better performance actually operating against Outlook as we have round trips back and forth between the Exchange Online infrastructure that's responsible for managing that data flow to and from the mailbox. So it looks like we're still going out and gathering some files from Outlook-related CDNs, but as we move through the UI here, things seem to be a bit better from a performance perspective. So in this case, we're now actually egressing that mailbox traffic locally in India. We're hitting a Microsoft Service front door in India for that traffic. And as a result, we're actually able to provide a much better end user experience with the service, regardless of where the tenant is located. So a couple key things to keep in mind here. The optimized traffic is what you really want to focus on. If you're going to do nothing else, find a way to optimize the path for that optimized traffic. The second thing that I really want to point out is while we showed a bunch of scripting that you could go and do on your own and try and adapt some of the samples that we have to your particular needs. In an ideal world, you don't have to do any of that. And that really comes from the work that we're doing with our network partners in the Network Partner Program to make this optimization process and this update process with the IP and URL web service as easy as a few checks, a few clicks in a UI. In order to make sure that you're always up to date and always aligned with our best practices. So hopefully that demo helped to drive home some of those points. A few last comments here. Definitely encourage you to take a look at the other videos in the network connectivity video series that we've developed. There's lots of great information there to help you optimize your on-premises network, help you future-proof your on-premises network to make sure that it's well aligned with our best practices, so you can have a great end user experience with our services as we continue to grow and add new features and add capacity around the world. Strongly recommend that you use the tools that we mentioned in the session today to help you identify and differentiate traffic effectively. If you're going to do one thing here, that we really recommend focusing on that optimized category traffic. Do whatever you possibly can to make sure that traffic is reaching Microsoft's infrastructure in the shortest path possible between the end user and the edge of Microsoft's network. And then obviously use our web service APIs to keep things up to date. Make sure that your infrastructure configuration is not lagging, and you've always got the latest set of service endpoints within your configuration. So thank you for taking the time to sit through this session. Hopefully you got something useful out of it, and look forward to talking to you on other network connectivity topics in the near future. Thanks.